you can't trust closed source implementations. But I think that's not news. That's what everybody thought before.
I store everything in this Microsoft D.
But the other problem is that even if you have like open source implementations like OpenSSL, you don't really know what it's doing.
Yeah.
Because, for example, if you have, for example, one implementation of one crypto algorithm in OpenSSL, then you have like thousands of files because it's like assembly code for each CPU, it's code for different operating systems, it's very mixed. You can't really see the algorithm on one screen. So you can't really see what it's, even if you compile it, you don't really know which code you have seen. Now,
you still have to trust the open source community
yes.
to really understood it and really check it. Yeah, and that's
yes,
especially with OpenSSL difficult.
Yes, that's the point.
Good.
Yes?
Am I saying it right that with every Bitcoin transaction you have the transaction address or data, which you can also see in blockchain info? And if I understand it right, if you have the wrong wallet software, the information about your private key is kind of leaked through computation in the transaction data, which is
yes.
open.
Yes.
So if you know that a certain transaction has been done with the wrong software, you can somehow extract the private key from the transaction data.
Yes, but this is the point. So all the information, all the private information is inside the transaction, inside the signature, so it's in the blockchain. So the attacker who made the malicious wallet just has to look at the blockchain and can extract the private keys. But this is made in a way, this is why here the pseudo-random number generator is used and the attacker's public key is used. It is done in a way that only the attacker himself can extract it.
And
So for everybody else, because it's pseudo-random, it's not distinguishable.
And can you use this system as a hidden payment scheme in the blockchain? I mean, because you can steal other one's bitcoins, you can also see it as a transaction which is meant to be. I mean,
You can only use your own random malicious key, and only you as an attacker can then generate a specific public address which looks random, but for you it looks like special because from that public address you can then derive the private keys.
Do you need to see two transactions with this
Yes.
malware?
Yes, you need to. But the first one is totally random. The second one just needs to know what K was used in the first one.
Okay. Because if you could only see the second one, you could always use your reverse algorithm, but then you would get gibberish if it's not one of your.
So this is the extraction algorithm, and here the numbers R1 and R2, that's the public part that you find in the signature. They are both used to extract.
You know them, I will find the data.
Any more questions?
Yeah, so what do you think about random number generators used by stuff like JavaScript for like what bit address uses, for example, to generate the keys?
I think that heavily depends on the browsers. I don't know much about JavaScript, but I think.
Can I make a comment? I, like, the end of last, some time ago, I was looking at the bit address. And I was trying to look for how it generates the numbers. So it depends on the browser. As you can use your, like, right now, you can use script library in your design JavaScript, but not all the time. There are many cases when you cannot really use it, and in this case, they fall back to at that time. I don't know how they do it right now, but at that time, they actually collected entropy from your screen.
Right.
Right now, I think you need to move, but yeah. Before, if you used your tablet with a touch screen, you can't really use your mouse. So they use some also, they randomness bits there. Then they use RC4, and my estimation, I said rough estimation, and we didn't, unfortunately, we decided to do something else. It was below 50 bits of entropy. So something. Well, no, it was something like in between 40 and 50 operations within elliptic curve multiplication, something like this. So it was, I mean, you couldn't break it, but it's not like you expect, huge entropy. I think I'm pretty sure I think they added something more.
Yes?
Were you motivated to write this paper by the blockchain.info leakage? Or were you
Related, but not really. But it is a little bit related because it all comes down to the fact that you have to choose this random number k randomly and
blockchain.info was between 0 and 255. So that's pretty random.
and yeah.
Really random.
But then you could intentionally make a weak random number generator that only makes a few values of k. But if you do that, for example, like it happened with blockchain info, then everybody would see it. But this attack is a little bit more sophisticated because these numbers k are generated in a way that only the attacker, because he has his private key, can detect it. For everybody else, it looks the same. So this is why there are some here these Greek letters, they are all constant that can be chosen in a way that that there are many different possibilities for this value z. And this is all, you can read it in the paper, that's in more detail. It's all done in a way that it has still a big space of random numbers. It's just that it depends on the number before, but it's not that the number of possibilities is not getting smaller.
It's actually like the skeleton key principle, right? You try to insert some data that you know that you can always hack it, but every other one can't see it.
Yeah.
So like this is the type of.
Any more questions?
How can we ever trust our Trezor or other hardware wallet?
Yeah,
Can't trust them anymore.
that's a very good point because it's hard to tell what's actually running on it. Even if you have the source code and compile it and put it on there, yeah, it's much easier with a PC because you can, it has to be like a clean PC where you don't have any untrusted software on it, but at least you can look at the screen and see what's in it. And with such a treasure device, it's hard to tell what's in it. Yeah.
What do you use yourself?
I use the Bitcoin Core client.
Sorry?
The Bitcoin Core client.
Trusted PC.
Yeah, on a trusted PC.
Probably with this double signature, I can just save it from the ledger.
Yeah, you mean,
Like
yes.
silencing your device.
Multi-signature
and then you
is-
still need another signature.
Yes, multi-signature is another solution. If you have two treasures, for example, and each one has its private key, and you need, or if you have two mini wallets from different vendors, and you need to then both to sign, then they would have to cooperate to protect you.
Oh, and maybe question unrelated to this attack, but one of the first slides it was that you needed a full client in order to sign transactions. Is that? I thought you only needed like a private key to sign transactions offline,
I don't think that I said you need a full client.
or a Bitcoin client or something.
Yeah, but that was just a very generic term, I think. But you don't need it, you just need it.
Isolated machine learning Bitcoin. Alright. But you have to have like a client in order to sign transactions and stuff like that.
Yes, but the client doesn't have to be a full-blown client that saves the whole blockchain.
Oh, right.
But it it has to be a client that knows how Bitcoin transactions look like.
Yeah,
Great.
yeah, to sign, yeah. Makes sense.
Sure.
Any more questions?